You may already know that in mathematics we build on a lot of previous material. So here's a particularly good example of doing just that. So now we're going to solve quadratic equations by the square root property, and then a little later the quadratic formula. Now we went over this in the flipped classroom video, but just to do some review. So let's write this one. 36y squared is equal to 4. Now, to use the square root property, we're going to try to isolate the y squared, the variable that is squared. We do so by dividing both sides by the coefficient of what's there. In this case, it's 36. So these then cancel out, and we now get y squared equals 436. Now you might say, can I simplify that? And the answer is yes, you can. Or you could do it now, or you could wait. But the simplification of this would be 1, and then 4 times 9 is 36. So we now have y squared equals 1/9. Now, once we've isolated the variable that is squared, the protocol is we take the square root of this side, and to ensure we get two answers, we go plus or minus the square root of that side. Now, the square root of 1 is 1, and the square root of 9 is 3. So the answer for number 1, our original example, is plus or minus 1/3. Now keep in mind this could have been factored, and as review, let's do it the older way. 36y squared minus 4 equals 0. Now we can take out a 4 from each one of these, and we get 9 squared minus 1 equals 0. That's 9y squared. Now this can be factored because their difference of squares will factor into their conjugates. So this is 3y plus 1, 3y minus 1, and then the shortcut, this will be a negative 1/3, and this will be a positive 1/3. So generally when answers come out like this, they could have been factored initially. But using the square root property is just another tool in your toolbox. Now for number 2, we're going to use the same property. Take a few moments. The first thing you're going to do is divide both sides by 3. Then you're going to take the square root of both sides, and let's see what you get. And should look something like this. Now another example, and I've written it up. Now the protocol is you take the square root of this side, anything that is squared, a base that is squared, by taking the square root of it, you just get the radicand. Now, let's simplify this a little bit because this is, you recall, the square root of 25 times the square root of 3. So I'm going to change this now to make it a little bit simplified here. So the square root of 25 is 5, the square root of 3. So now what do you do? Well, you're going to transpose this positive 7 to this side, becomes a negative 7. And I can get rid of it there, save a little room. And now how do we get what x is? Well, we're going to divide both sides by 6. And here the 6's cancel out, become a 1. X equals this. And we did it by using the square root method. And we simplified the radical form here by teasing it apart from an earlier lesson. All right, let me pause. Is there a question? Now, as we go on, I'd like you to write these two equations right about there if you have some room. And again, what's the name of this equation? This is the quadratic equation in standard form. Now, interestingly, if we solve this equation in this form for x, and we use the completing the square method, which we're not featuring in this term, you then get something that looks like this. Now notice you have an A, you have a B, and you have a C. A is used twice. And these are the A, B, and C that are in the standard form. But in this form, it's called the quadratic formula. Now, the quadratic formula is sort of a general formula that if you have a quadratic equation, and again, if initially it's in standard form, you can identify your A as 1 here. Again, we don't write it if it's 1. Your B as 16, and your C term is 64. So this is what they're asking you to do. So let's say over here, substitute your A, B, and C using this as a model and write it out over there. Did you get something like this? Okay, so now let's do the next step and calculate. This is a negative 16 plus or minus the square root. Now, when we square this, and I have this worked out, we get 256. And if I multiply this, this is a negative 256 all over 2. Well, under the radical sign, this becomes a 0. So you end up with a negative 16 over 2, which is a negative 8. So the solution of this equation is a negative 8. Now, we're going to be looking at this a little later. The word is here. What is under the radical sign, we call this b squared minus 4ac, the discriminant. And this discriminant determines the number and kinds of answers you're going to get. If the discriminant is 0, which is what it is here, you're only going to get one solution that is actually repeated, but one solution. If this is positive under the radical sign, you're going to get two solutions that are real numbers. And if the discriminant ends up being negative under the radical sign, then you're not going to get any real number answers. And we went over that in our video. Now, I don't know if you've noticed something here, but this is a perfect square trinomial that could be factored into a binomial square. This is y plus 8, the quantity squared. So if you were going to solve this, it's going to be y plus 8. Well, you don't need the parentheses, equals 0. So y here equals negative 8. And that's what we got using the quadratic formula. Now, we could have factored this, but the quadratic formula works as well. The quadratic formula is a general way of solving quadratic equations. All right, let's go on. Now, for number 5, it wants you to solve this using the quadratic formula. And is this in standard form? And the answer is no. So let's put it in standard form together. 16x squared minus 24x plus 9 equals 0. Now, why is that crucial that this is in standard form before we put our values into the quadratic formula? And the answer is we have to identify the A, the B, and the C when it's in standard form. Because if we use this as a C, it would be a negative here, but actually it's a positive in standard form. So that's critical. That's how the quadratic formula was derived when A, B, and C were in standard form. So our A is 16, our B is a negative 24, and our C is a positive 9. So over here, substitute these values into the quadratic formula, and let's see what you get. As we look at this, did you get this in substitution? Now notice here this is negative, so this part will be negative. Well, when we square 24, we get 576. When we multiply all of this, this becomes a negative 576. So our discriminant here is going to be 0. So then we're left with 24 over 32. And we can take an 8 out of there and get 3. And an 8 out of there and get 4. So our answer is, again, our discriminant is 0. So there's only going to be one answer that is repeated. And it's 3/4. Now, looking at this again, this is a perfect square trinomial that would have been factored into this. And write this down. This is going to be 4x minus 3. So again, if you solve this, The 3 comes over as a positive 3, and you divide by 4, and you get the same results. So this is a perfect square trinomial, could have been factored. And we also, putting this in standard form, could put it in the quadratic formula. All right, let's go on to our next one. Again, hopefully you're asking questions if needed. Okay, now for number 6, we are particularly looking for the discriminant. And remember, the discriminant is what is under the radical sign in the quadratic formula. And is this in standard form? Yes, everything's on the left and it equals 0. So to find the discriminant, we have to define what is our A term here. Well, our A term here is a negative 2. Our B term is 6. Our C term is a negative 3. So take a moment now and find what the discriminant is by substituting. All right, so that'll be 36 minus 4. A is a negative 2. C is a negative 3. Now, notice what's happening here. You have 3 negatives. So the product of this is going to be negative, which is 8 times 3 is 24. A negative 24 from 36 is going to be 12. So your discriminant is 12. What does that mean? Well, since under the radical sign it's going to be positive, there's going to be 2 real solutions. And while we're here, simplify this. And did you get the square root of 4 times the square root of 3? Square root of 4 is 2. The square root of 3 from an earlier lesson. You're going to need to be able to do that on your examples in Certify and then later on the test. Okay, we're getting some challenging work here. As we look at example 7, there's our quadratic equation. But notice our A term is negative. My suggestion to you at this stage is try to keep your A term positive. It's much easier to solve when the A term is positive. So rather than bringing everything over to the left, I'm going to move this term over to the right, and it now becomes 2y squared minus 3y minus 1. And there would be a 0 over here, but I'm going to just put this 0 over there. So what I did is I transposed this and then equaled it to 0. So now when I define my A, B, and C, I can have A as positive. So this is 2, this is a negative 3, and this is a negative 1. All right, now put these into the quadratic formula. So a negative B would be a positive 3 plus or minus the square root of 3, a negative 3 squared is 9, minus 4, it's in the formula. A is 2, C is a negative 1, and this is all going to be over 2A, which is a positive 4. Now, another thing, as you look at the discriminant here, notice that this is negative and this is negative. You have 2 negatives, So this is going to end up being positive. So we can make it positive. So now we go 4 times 2 is 8. 8 and 9 is the square root of 17. And there is our answer. Now, again, if they're asking you for the discriminant is going to give you, since it's positive, 2 real number answers. You click on that dot, and then they're going to give you 2 boxes to put your answers in. And as you put them in, you're going to go 3 plus the square root of 17 over 4, 3 minus the square root of 17 over 4, 1 in each box. Now, why I'm saying having A is positive, you don't end up with a negative in the denominator. Mathematicians don't like negatives in the denominator. So keeping it positive, it comes out the same. It's just a little tricky the other way. All right. Now, for these last two, we're going to let you do them, but here we're using the square root property. And let's see what you get. Okay, the first thing we did here was to divide both sides by 2. And this gave us then what we have in parentheses equals 20. Then we took the square root of both sides. And if you recall, the square root of 20 is equal to the square root of 4 times the square root of 5. So I simplified that as 2 the square root of 5. Transpose the negative 7 over as a positive 7, and there's our answer. Now, in some cases, you can put this into the software using the plus or minus sign, or if they ask you to write it separately, one would be plus, one would be minus. Any questions on this one? All right, number 9. Again, I've just written it out. Took the square root of both sides. Here I just get my radicand. Plus or minus the square root of 121. 121 is a perfect square, so that's 11. So then I transpose my 7 over as a negative 7. But I don't have the answers yet. A negative 7 and a negative 11 is y equals a negative 18. And then a negative 7 and a positive 11, y equals 4. Now, when you get answers like this also indicates that this could have initially been factored. And I think we spent enough time, so we won't show you that, but actually I have that work on my paper that expand this, move this over, these end up being the factors. All right, let's wind this up. Under 25 minutes, it was a long lesson.